Hello students. So in this lecture of electronics we will learn a new concept, and it is very interesting and it is a very conceptual topic. It is asked in the examinations and it is asked in the interviews, and it is a very fundamental property when you are studying the amplification by transistor. And this topic is the phase reversal in a CE amplifier. When you have a CE configuration, in that configuration what you observe that there is a phase reversal between the input and the output signals. Means the input and output signals, they are differing by phase. So here we will learn what is the reason of phase reversal and how does it occur, how can you explain. Suppose in the examination you are asked that show that the input and output signals in a C amplifier are out of phase, they differ by phase in 180 degree. Then how will you show this? So let us try to understand the concept. The first thing that you should understand that what is the meaning of the phase reversal or phase change in CE amplifier. Many times we ask this question in the Viva voice examination, and the student says that the input and output signal, they differ in phase by 180 degree. But what does this actually mean? What is the basic concept that you should understand? What is the basic meaning of phase reversal? So phase reversal, it is correct that there is a 180 degree phase reversal. When we ask the student to describe it more properly, he says that the signal changes its shape by 180 degree in the output. This is not correct. So what does phase reversal mean? It means that when the input signal increases in the positive sense, the output signal increases in the negative sense. This is the meaning of phase reversal. Amplification is occurring many times in very few cases, although we have encountered this problem that the student has a conceptual misunderstanding regarding amplification, and he asks that how does the amplification is taking place. Perhaps he has not studied the topic properly. What he means to say is that if this is the input signal, then the output signal is like this. Okay, maybe it is all right. But whenever you are asked that what is the meaning of phase reversal, you should understand, you should answer it in this way, that when the input signal increases in the positive sense, the output signal increases in the negative sense. This is the meaning of phase reversal. Now, how does the phase reversal occur? So this is a circuit diagram, and you now at this stage, I think you are able to understand this circuit diagram, that this one is the biasing circuit with the voltage divider bias. I have explained in the previous lecture, voltage divider bias. And this is the best biasing that can be used in an amplification process or in a transistor where we are focused to increase the signal or amplify the signal. The stability factor is equal to 1. We have explained these things, we have understood these things in the previous lecture. You can watch the lecture, that will be in the I button. So here we have this circuit. R1 and R2 are the components of the voltage divider circuit. Now the input signal is fed to the input end of the transistor, and you have to always remember that the input signal in a CE amplifier, it is provided at the base emitter junction, it is forward bias, base collector junction, it is reverse bias. So suppose this one is the input signal that is fed at the input end of the transistor. It is fed to the base because it is a CE amplifier. The base emitter junction and is forward bias, and the output is taken here, that is the base collector junction. Now what happens in the base collector junction, emitter collector junction, at the output end you get the signal like this. And this is the point where many times a student is confused what is happening and how it is happening. You see the positive peak here, it is negative peak here. It is not that the positive is becoming negative. You have to understand the definition that during this positive peak of the input signal, the output is increasing in the negative sense. It is not that amplification is not occurring. You can say that during the positive half of the input signal, the output is increasing in the negative sense. This is called phase reversal. Now the instantaneous voltage at the collector emitter end, it is given by this equation. Now let me remind you again that the small letters, the small designations are for AC and the capital letters are for DC. This is AC. This is the collector CC voltage that is used to bias the collector. This one is the VCC, which is reverse biasing the collector base junction. You have to remember this. Small letters for AC, or if you require, I can make a short 5 to 10 minute video regarding the designations. Now during the positive half cycle, what is happening? The input part of the AC signal, it is increasing the base signal or base current, that results in an increase of IC. If IC is increasing, then the voltage drop across collector, I am writing voltage drop, D means drop, across collector, ICRC, this is also increasing. So you can see that the term with the negative sign, it is going on increasing. Let me give you a very crude mathematics. This is first 10 minus 5, it will be 5. Then this part is increasing, 10 minus 6, 4. This is again, it is increasing. It is suppose 10 minus 20, it is minus 10, 10 minus 40, it is minus 30. So this negative part, the part with the minus sign, it is increasing. And what is happening? VCE, the collector emitter junction the collector emitter voltage or the output voltage, it is becoming negative. It is going to the minus sign. It is not reducing. So ICRC goes on increasing, VCE goes on increasing in the negative direction. It is not that it is reducing. Many times times and again I am discussing this thing, because during my experience I have seen that students are confused in this thing, and many times their answer confuses us that what he is trying to say. VCE, the AC voltage at the output, it is increasing in the negative sense. You have to understand this. And this is the phase change. This is the out of phase condition. And you must remember that the amplification is not affected by phase reversal. You can check this if you are asked in the examination. You can check this by differentiating this equation. VCC is constant, so it will be 0. DVCE, it will change only with this IC, and it is minus IC. So any change in the collector output voltage is negative, and this negative sign implies phase reversal. Negative sign implies phase reversal. This is called phase reversal. Now you can understand this graphically. You can get these diagrams in any textbook. I have already told you that in any of the electronics textbook you can get these diagrams. Here you can understand the things in a more comprehensive way. Let me explain it to you. Now this is the graphical representation. This graph is very well drawn in the book by V.K. Mehta. You can take that diagram. Apart from this V.K. Mehta, there is Boylsted and Amos and Smith, and there is Ryder. But they have given the explanation in a brief manner, means that you have to know several things before going to that explanation. So I am going into the detail of the explanation. This is the graph that you can see. Now in this graph, what you have, first thing that you have AB is the DC load line. I will discuss the AC load line also. Is the DC load line. You have learned the concept of DC load line. It is used to find the Q. It is used to find the Q point. Now you see in the diagram, this is for a simple circuit. We have the base current that fluctuates to plus minus 5 microamperes. This is the base current. This is IB. IB fluctuates by plus minus 5 microampere. Means IB can be 10 microampere. If you are adding to this line, it will be 10 microampere. Then minus 5, it will come to 0 here. 10 microampere or 0. So this is the first condition that is observable. And this is occurring at the zero signal base current. You have to remember this. At zero signal base current means when there is no input AC signal. Zero signal base current. This is the condition. When there is no base current. When there is no input AC. Now when the base current is maximum in the positive direction, the collector emitter voltage that is on the x-axis, it becomes maximum in the negative direction. Now let me explain through this diagram. You see this diagram. This is the, suppose this is the 10 microampere base current and it fluctuates by plus minus 5 microampere. Sorry, it is 15 or 5. It is 5 microampere. Now, when the input signal it is maximum during the positive peak, the base current goes to 15 microampere and this is the point G. Now, this point G is reproduced by this dotted line along this line, and this is the negative direction in the output. It is the negative. This one was the positive and this is the negative part. So when the input signal is increasing to the maximum value in the positive sense, the output signal is increasing to the maximum value in the negative sense. This is for 15 microampere. Now suppose the base current goes to 5 microampere, means it is minus 5 microampere. It is going to plus 5 microampere. In this case, the output signal VC is maximum here. Now, if you reproduce this point, you observe this point backwards. This is the input signal. So, when I see the input signal is minimum, it is reaching the negative direction, the maximum in the negative direction, the output is reaching the maximum in the positive direction. This is the meaning of the phase reversal, phase opposition. So the input and output voltages, let me write this thing in detail. From diagram, when base current IB is 15 microampere, it is varying by plus minus 5 microampere, I have written this. Then the point G corresponds to the value of, now this, what are this G and point H? This is a coordinate I have told you already. This is the value of voltage and current. The current value is 15 microampere. The voltage value is in the negative direction, minus ICRC. If you reproduce this voltage backwards, corresponds to the value of point G. When this point I am writing in a very simple language, is extended downwards, it shows the negative maximum or the maximum in the negative maximum of VCE. So when IB is increasing, when this input current is coming, it is changing the IB from 10 microampere to 15 microampere. This is the positive part. The positive part of input signal causes the base current to increase. Let me give you this diagram here also. Increases the base current to 10 plus 5 microampere and it is 15 microampere. The output increases in the negative direction, and this is reflected by the point G in the figure. When the negative peak of input reaches the base, it reduces base current to 10 minus 5 microampere and it is equal to 5 microampere. Now at this 5 microampere, the point H, it corresponds to the positive peak. So during the negative half of the input signal, the output increases in the positive sense. This is the meaning of phase reversal. And now you are, I think, in a better position to understand this output characteristic. This input signal, it is changing by this base current by some amount, decreasing and increasing. So the output signal is in match with the input signal. So amplification is occurring. There is no change in amplification. Don't think that phase reversal or phase opposition will cause the amplification, will change the amplification. The simple thing is that there is a phase reversal by, from the diagram you can see it is 180 degree phase reversal. This diagram and this diagram. This is a phase change by 180 degree. Amplification is totally unaffected. There is no change in amplification. And the most important thing that you should remember, that phase change or phase reversal occurs only in CE configuration. Now it is your task to show me why it is so. If you wish, you can tell me. Phase reversal occurs only in CE configuration. No phase reversal occurs in CB and CC. No phase reversal occurs in CB and CC. Now this is a question. I think you should think on this question, why it is so, and then we can discuss, or if you wish, I will discuss it in a separate lecture. So this is the concept of phase reversal. In the next section, we will see some equivalent circuits for amplification, DC and AC circuits, and the load line analysis, the AC and DC load lines. So we have understood the DC load line, we have to understand the AC load line also. So for the time being, stay tuned and please like, share and subscribe the channel and watch the videos. If you have any queries, then let me know in the comment section.